Ladies and gentlemen, I have before you a few examples of graphical representations, and we're going to find the limits, but we're going to look at something called one-sided limits. Technically, one-sided limits really aren't true limits, but they're darn useful in interpreting and understanding limits, and they'll pop up quite a bit. So I've got three examples, A, B, and C. This first one is the function f. So we've already done this before, so we look at f. Now, the one thing we might not have seen, there are these superscripts. They fly through the air like Superman. They're a little higher. So these superscripts, that little negative sign means what's happening just a little bit to the left of 0. And this right-hand side is saying, hey, what's happening just a little bit to the right of 0, so kind of the right-hand limit. So as we look at this first graph, as we get close to 0 coming from the left, the function seems to be approaching 1. And when we come from the right-hand side, the function seems to be approaching 1. I even threw this down here. This is not calculus. This is really just function notation. What is the value of my function when x is 0? Well, the exact value there is 1. Now, this is where one-sided limits are really handy, because if the left-hand side limit and the right-hand side limit approach the same value, that means our two-sided limit, or just our regular limit. It's really just called the limit, but that means our limit is going to be defined. And if they're both approaching the same value, we already know what that limit's going to be. But oh ho ho, now we're looking at it at a different point. What happens at 1? What's the left-hand limit and the right-hand limit? As I approach from the left-hand side, it looks like my function gets closer and closer to 2. As I approach from the right-hand side, my function gets closer and closer to 4. Well, now those two limits, while they do exist, I know the left side and the right side, they're not approaching the same value. I'm going to say this is undefined, or it does not exist. What is the actual function here, though? Think about it. This isn't calculus. This is the actual thing. You have a couple open circles, one full circle. It turns out the original function, the actual function itself, at 1 is 3, that middle dot. But only at that number. If you go anywhere to the right or left, you get different values. And so now we're going to look at some of these other functions here. We have the g function. I wrote this down. This is the only function I actually wrote out, because we're going to see a number of these absolute value situations. And they really just become a piecewise function. Everything to the right of one value is 1, everything to the left is -1. So you'll see a lot of these split. And then this is a square root function. And if you have any function in which the domain is not all real numbers, that means you might have a boundary somewhere. You might have a boundary where it just stops right there. And what happens to your limits? Let's take a look. Here's the examples for B. Notice that I've changed the function to g, because that's my second example there. And as I come from the left-hand side, the actual function is -1. As I come from the right-hand side, it looks to be +1. What does that tell us about the actual function? What we could think of as the two-sided function, but we're just going to say, hey, this is the actual limit. The limit, as x approaches 2 of g is, well, it doesn't exist. It does not exist. It is undefined. The set of solutions is the null set. And then finally, if we're looking for the actual value at exactly 2, we find out, wow, that doesn't exist either. Does not exist. So it turns out that there's no function value or limit there. And now example C. And we should pay particularly close attention. These are very confusing. When you start seeing negative numbers and then a left or right-hand symbol, try not to get confused with the number, the negative that's in front of the number and the positive or negative that is a superscript on the other side of the number. But so for something that might have an endpoint or a boundary there, we can see the left-hand limit, well, it just doesn't exist. It is undefined. The right-hand limit seems to be approaching -1. The actual point there is at -1, but that means that my two-sided limit, or as I would say, my limit does not exist there. One-sided limits are just as easy as any other graphical. They're great.